In this section, you are going to learn about monitoring the cloud environment, monitoring resources, and how that's a key component in ensuring the ongoing success of cloud computing. Proper monitoring leads to increased availability for servers, services, applications, and it helps to uncover problems early on. It also helps organizations to identify network outages very quickly and efficiently, in addition to allowing organizations to plan for future resource utilization and really ultimately to become proactive instead of reactive. Understanding this is very important as a cloud professional, and that's what you're going to learn in this section. In any environment that we find ourselves in, monitoring resources is going to be a key component. And certainly in a cloud environment, it is critical. We have so many resources that it's critical for us as administrators to know what's happening with those resources. So it says here that monitoring is critical to provide quick and efficient responses to network outages. It also helps us, though, to identify that network outages might be coming in the future. Right? It leads to increased availability for servers, services, applications. It helps us to uncover problems early. It helps us detect and deal with network outages quickly, and it helps us know what we're going to need for the future. We need to understand how to monitor because it's going to provide the ability to plan for future resource utilization requirements. Helps us to become proactive instead of reactive. In fact, that's really the best approach. A reactive approach to monitoring just says I'm going to sit back essentially and wait for something to happen. And when it happens, then I'll monitor the resources. Then I'll deal with it. That's not the way to go in really any environment, albeit that in some environments the resources are a little less critical, so we sort of just adopt that fashion or adopt that mentality because I'm not going to spend time, for instance, proactively monitoring client computers. But I will spend time proactively monitoring my virtualization hosts that are the framework of my cloud environment, because a failure or a lack of performance in those systems is going to extend to other systems, and it's a very critical part of the network. Proactive says we're going to put monitoring in place so that we're immediately identified when there's a problem. We're immediately identified potentially even when there's the hint of a problem. And so that we have these great reports so that we can identify trends and be able to plan for the future. That's a proactive approach to monitoring, and that's the approach that we want to have. So monitoring is important, but how should we go about doing it? That's going to kind of be the focus here is what are the techniques? Well, let's start by some general rules. Effective monitoring techniques are officially going to monitor all parts of the cloud environment. Okay? And they're going to do so without placing a major performance strain on the environment itself. See, sometimes when we monitor, we have the disadvantage of causing a performance hit because of our monitoring. And we don't want to do that. All right, we don't want to place a performance strain on there. We want to be able to manage performance of the enterprise along with giving detailed information on the current utilization of the cloud environment. This type of monitoring is going to provide us with numerous advantages. Okay? Now we know cloud computing itself provides us with numerous advantages. This gives us an efficient way of load balancing, scheduling tasks, allocating resources in a dynamic and elastic fashion. Well, monitoring those resources is also going to be an important part of maintaining the environment. The advantages that monitoring is going to provide is a mechanism for chargeback. In fact, performance is a key metric for chargeback. The chargeback, remember, is just the amount that we are going to charge a particular business unit, division, or customer for the number of resources that they have consumed. Well, having proactive monitoring that shows specifically the amount of resources that they have consumed is going to provide us with that ability. Okay? Also provides resource provisioning and planning. being sure that individual customers have the number of resources that they need. Planning for future growth. We already had mentioned being proactive helps us to analyze trends and identify when a particular customer will need more, or when the number of customers that we as a cloud provider have consuming our resources has reached such a point that we potentially could run out of resources, and so we expand. I know we've mentioned that from a customer's perspective, the cloud computing model seems to be this inexhaustible set of resources. Well, it's not really inexhaustible, right? There is a limit to the number of resources that you can consume. Now, from a customer standpoint, the limit is what I pay for. From the provider standpoint, the limit is what I have. With monitoring, we can ensure as a cloud provider that we always have more than what somebody is willing to pay for. So we plan for future growth in that way, plan for the distribution of compute resources. To put it bluntly, I mean, without proper monitoring, it becomes very difficult to respond quickly in a cloud computing environment that is constantly changing. So we must be proactive in our monitoring. This is a very big part of operating in a cloud computing environment. Now, when we're defining a monitoring solution, it's important for you to understand that different protocols are available for monitoring, and there are different protocol options that are available for administrators to be alerted of problems that might arise in the cloud environment. Okay, so not only are there different protocol choices, which we'll go through, but there's different ways that we can be notified and those kinds of things. So one of those ways is notifications, some form of notification to an administrator that there either is a problem or there is potentially a problem and whatnot. Publishing information, for example, to a dashboard on a company intranet site to validate SLAs. This is done a lot in enterprise environments with products like SharePoint or other intranet website products, where individual little widgets or dashboards can be produced, and they are displaying key performance metrics for that business unit or for the IT department, and it helps us to validate SLAs. We might produce scheduled reports in order to identify the particular counters and metrics that are being measured to provide chargeback, but also to provide monitoring and things like that. Okay, so these are different options depending on the protocol and monitoring solution that you choose. They may not all be available to you, but it's something to be aware of. Now let's get into the individual protocols that you can utilize for monitoring in a cloud computing environment. And probably one of the most well-known protocols is the protocol SNMP, Simple Network Management Protocol. And it's very popular for managing and monitoring an environment. One of the reasons that it's very popular is that it's commonly supported on devices like routers, switches, printers, servers, and it can be used to monitor those devices for any issues or conditions that might arise on the device that would necessitate administrative attention. Okay? It gathers information from those devices, and it gathers information based on the network vendor. So each vendor will have its own set of info that can be obtained. It also gives us the ability to modify the configuration of those devices. So it's not only something that can be used to glean information, but something that can be used to change information. In fact, we can configure thresholds on the devices. We can configure agents to forward alerts, which are also known as trap messages. Now you might be thinking, well, what is an agent? Let's talk about the two major components of SNMP. The first component is a management system. The management system is an administrative computer. Okay? It could be called management system or simply manager. And this is the system that monitors or manages a group of network devices. Each managed device constantly executes a software component called an agent. And it's the agent that reports information using the SNMP protocol back to the manager. All right. So for example, a SNMP agent on a router could provide information about the router's network configuration and operations, its network interfaces, routing tables, et cetera. And it could transmit that information back to the manager. And the manager could, in turn, ask the router to alert it of a situation where it had an interface that was down. And that would be then configuring the router to use a trap message. And there are a variety of vendors that use SNMP to monitor devices. They use information from SNMP to give an administrator a means of monitoring and managing network performance, but also a way to report, to troubleshoot network issues, just better understand and prepare the network for these kinds of changes. So SNMP is the first protocol and a very common one for us to use. Another option for monitoring an environment is the Windows Management Instrumentation Framework, which is Microsoft's version of Web-Based Enterprise Management, or WBEM. WBEM is an industry initiative to develop a standardized way of accessing management information in enterprise environments. So what WMI does is it gives you the ability to write scripts to automate certain administrative tasks, and then you can run those scripts against remote computers. Those scripts can gather inventory, they can gather performance information from workstations, servers, applications. You can gather hardware information from one server or multiple physical servers or even virtual machines. And then you can put that information into a centralized database, which would allow an administrator to quickly view a ton of information about the CPU, the memory, the operating system, the hard disk, those kinds of things. So this is heavily used, obviously, in Windows environments because it is the Windows management instrumentation. It is used by products like Microsoft System Center Config Manager, SCCM, to gather hardware information from clients. It is utilized by Virtual Machine Manager as well, or can be utilized in order to gather information from virtualization host. And it's accessible from within Windows PowerShell. And Windows PowerShell is the command line administrative tool of choice from Windows Server 2008 and on, supporting PowerShell remoting. So the ability to use the getWMI object commandlet in order to gather this information from a remote computer. The next option that we have is called out-of-band management. Out-of-band management allows an administrator to remotely manage and monitor a device even if that device is not turned on. Okay? If you want to use out-of-band management, you're going to be using what's called the Intelligent Platform Management Interface, or IPMI protocol, to monitor the environment. This protocol operates independently of the operating system, and so that allows the BIOS settings to be monitored and or configured in some cases. So out-of-band management is a useful scenario, especially when you consider remote administrative requirements. And so if you have remote administrative requirements and a system's turned off, what are you supposed to do if all you can do is connect to the operating system? So it's the out-of-band management that's typically enabled in these kinds of environments so that I can remotely boot the machine or remotely access the machine even when it's turned off. Another very common way of monitoring resources is syslog. Syslog provides a mechanism for network devices to send their event messages to a logging server or syslog server using TCP or UDP port 514. Syslog is also supported on a wide range of devices as the capability of logging different types of events. Sounds similar to SNMP, but it is a bit different in that it does not have the ability to pull devices to gather information like SNMP. It simply sits there and gathers messages that are sent by various devices to a central syslog server, and those events are sent when a particular event has been triggered. All right, so it's just essentially the ability to consolidate logs from multiple devices. I've always questioned whether syslog could actually be considered proactive monitoring, because again, we have to wait for something to have occurred before we are actually alerted of it, but it is still a good way to gather that information centrally. So now that we've gone through various options, protocols that could be used to monitor the environment, we need to talk about some other concepts. Regardless of the protocol that you select, an organization still needs a way to be alerted when certain events occur. Okay? It's important for us to notify of the occurrence of failure and other events. So for example, if a company's monitoring a server and that server loses network connectivity, well, I need to be notified of that. Why? So that I can fix the issue. It's whatever issue happens to be causing the problem. So a lot of vendors offer network monitoring and alerting solutions. They offer them for both on-prem and cloud-based deployments. Many will offer some form of website or web service that will be used to centrally monitor an organization's cloud environment, whether the cloud is private or public. Okay, we've also got the SNMP traps and syslog errors, things that we had already mentioned. You have short message service or SMS, and even SMTP, email message notifications. And there's my public cloud vendors that will give dashboards on websites alerting to problems. So, those are the different options. SMS text messages, email messages, the traps and the syslog errors, you probably have to go to the management system to actually be able to see. And then the website that would alert to problems, you would be able to go on and see. An example of that is Office 365. In Office 365, we can go to the service health page in the Office 365 portal, and we can immediately identify if certain services are up and running or have degraded service or are completely unavailable. And that would be an example of the public cloud vendor and those types of alerts. Another concept that's important for us to understand is the concept of baselines and also thresholds. Baseline is a standard of acceptable performance. This is something that is going to be established by a company by selecting a sampling interval and the server or the resources that you wish to monitor. Now, it's important when doing that to choose a smaller interval. That's just because of disk utilization. All right, if you create a lengthy sampling interval, it's going to consume potentially a large amount of disk space and bandwidth, especially if the network is gathering a baseline. We want a time frame that's going to give us an accurate analysis to use going forward, but we want it to be a smaller interval as possible. Okay? That time frame does still need to include lag times and peak times in order for us to have an accurate assessment. What do baselines do? Well, the purpose of establishing a baseline is to create a sample of the computing resources that are being consumed by the server over a period of time. That helps us because it gives us this point-in-time performance chart of the environment. It can be used in turn to help identify anomalies when troubleshooting performance. If the server's performing sluggishly, or users say a database is responding extremely slowly, well, then I can use the baseline to compare the performance of the server when it was performing well to when the user reported it as a slowdown. I've always said baselines are not necessarily required to identify the extreme, but they also very much help to identify trends. And so we can see trends in performance, an overall degradation of performance over time, or an increase in performance by looking at the baseline. They still are used when troubleshooting to identify any differences from the standards that we have established. The other purpose of baselines would be to establish alert thresholds. So we mentioned both baselines and thresholds. We come up with the baseline values, and then we come up with the specific level at which I want to be alerted. So a user has reported a problem, and I say, look, if the user reports, or if this server, this database reaches this level again, we need to go ahead and be notified. If you think about it, that's a very much a proactive way of doing it, saying I don't want to wait for the support call to come in. I want to know when this counter reaches this particular threshold. And the baseline helps me to know what's appropriate for those values. Now, the last concept that we want to talk about with monitoring resources is something known as automated event responses. While monitoring and alerting are great ways to minimize problems in the cloud environment, there are some issues that arise with these features. Right? When I have monitoring and alerting on all the devices, the amount of alerts that arise could actually be fairly staggering. If I get too many alerts, I don't have enough time to respond to those alerts. Some things may go unnoticed. They may not receive the attention they deserve. And that's where automated responses come in. Okay. So these automated event responses can save administrators considerable amount of time, allowing their focus elsewhere. So for example, if an administrator gets an alert that a hard drive is at 99% capacity, instead of having to go in and manually clean up the server, delete files, run a disk cleanup program, why not just automate the task? And so it responds to simple non-critical events. That may have not been a non-critical event example, but simple non-critical events in real-time automated fashion. Essentially, automated event responses are scripts and commands that execute in the case of particular alerts, taking away the responsibility of the administrator to go and manually perform those same tasks. And in so doing, they will significantly ease the administrative overhead. So once we've come up with how we're going to monitor, then we've established baselines, configured thresholds, and then we can configure these automated event responses as events occur. And I look at them and say, well, in the future, I don't need to be bothered of this. You can see how a lot of this monitoring is going to require some ongoing attention and fine-tuning over time in order for it to be successful. But it's a very key and important part to the cloud computing environment. In this section, you learned about the importance of monitoring resources. Being proactive in your monitoring approach to a cloud computing environment ensures ongoing efficiency, the best performance, and the best high availability. Now, as you learned, there are several different monitoring techniques along with various protocol options to choose from. So we discussed protocol options like SNMP, a very popular monitoring option that's commonly supported on network devices that results in those network devices reporting back to an central management system. We also talked about WMI, the ability to query information from some devices running Windows. Syslog, another common option when it comes to network devices. And we discuss other features and characteristics of monitoring, such as baselines, alerts, thresholds, and automated event responses, all in an effort to get you ready as a cloud professional to monitor your environment to ensure its ongoing efficiency.